Okay, welcome to this review for Econ 382. This is going to be a super helpful review. I'm so glad you showed up. I will do my best to prepare you to get an A on this exam. Okay, so what I'm going to do is I'm going to really quickly just overview the concepts that we've gone over so far in class, and then we can take some questions. We'll have take questions as we go along too. Just let me know things that you guys want to cover, and then if we at that point that shouldn't take super long. And if you want, I have a little practice exam that I wrote up, so we could go over that if you so desire. Okay, but just talking about Econ 382. Okay, it's kind of like Econ 380. You guys remember from Econ 380? You have a graph of the difference curves like this, x and y. All right, here's some persons in difference curves. Okay, but this is not 380. This is 382. So we want two of those. So we're just going to flip somebody else on the top there, and so we'll draw some more indifference curves, just like that. And there we go. That's,
that was clever. I'm going to remember that actually a lot better.
Yep, there you go. That's good. So we call that an Edgeworth box. Okay, so you got two consumers. Right down here we have Bob and Heinz. Okay, there. So these are our two consumers, and so their indifference curves this is a way to just compare their indifference curves with this Edgeworth box right here. Okay, and so both of them want to get as well off as they can, and so you might have an allocation like this that one person cannot be made better off without the other person being made worse off. We call that what? Pareto efficiency. Exactly. And that doesn't have to be there. It can be, maybe this is your allocation. You end up right there, right? Is that Pareto efficient?
Yes.
Yes, it is, because you can't make one person better off without making the other person worse off. It's Pareto efficient, but it is not equitable, right? Because Bob has a lot of both, and Heinz has very little. So we could map out, a bunch of Pareto efficient outcomes like that. And that line is what we would call a contract curve. Contract curve is all sets of Pareto efficient outcomes, okay?
What is the equilibrium condition specifically for the indifference curve? So what is the...
Yeah, so it depends on, good question. So it depends on endowments. So basically, these people, I've just illustrated demand here, but since it's economics, we don't want just demand, we want supply. So we're going to make up supply, and supply is going to be a function of endowments, stuff we're just going to give these people, and that's going to be our supply. So in this case, we'll give them some labor, and we'll give them some capital. Let's say that Bob has he got 24 hours in a day, so L could equal 24. Actually, he's probably not going to work 24 hours, so say he's willing to...
14.
14? Okay. Bob can work a maximum of 14 hours. So Bob's got 14 labor hours. This is a supply of L bar. Well, that's the endowment of L for Mr. Bob here, 14. And we'll say he's got a computer that can run 24 hours a day. Okay, so he's got 24 capital hours there. All right, for Bob, right? So we've now given Bob an endowment. Let's give Heinz the same endowment. Equals L Heinz. Okay. All right. So now we've given them endowments. So now we have supply, right? Our labor supply is going to be 28, and our capital supply is going to be 48. Okay. And no. Okay, that's the total capital. All right. So now we have supply functions. We can solve, if we have utility functions for Bob and Heinz, we can solve for their utility functions, their demands for x and y, and then we can set supply equal to demand, and boom, we have what you call an exchange economy, where we can solve for equilibrium. And equilibrium will depend on what these endowments are for Bob and Heinz. Right now I've set them as equal, so probably going to end up right in the middle there. But you can imagine that I could give them different endowments, and they might exchange, and they might, they will reach an equilibrium, assuming perfect competition. they'll reach an equilibrium on this contract curve. In fact, that is what we're going to call.
There's a budget constraint of some kind, right? And
Well, yeah, they both have budget constraints too. Well, yeah, I mean they both have income, right? So when we're solving the supply and demand problem, their income is the value of their endowments. So let's say that the wage that they can get is $2 per hour. And let's say their computers, every hour their computer works, it makes them $1, right? So in that case, the value of their endowments would be WL plus RK. So the value of their endowment would be 2 times 14 plus 1 times 24 equals 52, is that right?
Wait, we got 20.
Yeah, I think that's right. Okay, so that is their income, right? It's just the value of the endowments that they hold. Okay, so that's how we solve income in that case. But the way that equilibrium can work in these, like I said, it depends on the value of the endowments. And there's what we call the first and second welfare theorems that describe how Pareto efficiency and the contract curve work. And so the first welfare theorem says that in perfect competition, every equilibrium outcome is Pareto efficient. Okay, so assuming we're in a world where perfect competition holds, then we can just observe that when people trade, they reach equilibrium like by themselves, no intervention from us. They will reach one of these Pareto efficient outcomes. Okay, does that make sense?
Can you
That's
say that whole thing again? Sorry.
Yeah, basically, it's just like the invisible hand, right? So everyone has their own labor and capital that they've been endowed with, and they're going to do their own thing, and they're going to trade with each other. And in perfect competition, we know that they will reach a Pareto efficient outcome in equilibrium. Okay, that's what we call the first welfare theorem, is that they'll reach a Pareto efficient outcome on this contract curve. All right. Now, the second welfare theorem says that if I want to reach any Pareto efficient outcome on this curve, I can actually do that by just redistributing their initial endowments. And that's all I have to do. And then if I do that right, then they can trade. Like let's say they reach a Pareto efficient outcome and they end up here. And I'm like, well, I think Bob still has like too much and Heinz doesn't have enough. That's not very equitable. So I'm going to take all their endowments, I'm going to mix them up, and I'm going to redistribute them to Bob and Heinz in such a way that when they trade again and we reach equilibrium, I can make it so they reach this point. That's the second welfare theorem. It says that I can choose any point in this contract curve, redistribute their initial endowments, and make them reach there. Yes, Patrick.
Could you rephrase that as, like, for any point on the contract curve, there exists an endowment that will, like, there exists at least one endowment that will result in, like, reaching that point?
Yeah, I would say there exists a set of initial endowments. So all I do is I give them their initial endowments, and if I give them the right set, then they'll reach that point. Yeah.
So could we go over quickly the process of going from a utility function with an income to a px over py all the way to an equilibrium point? Or is that going to take too much time?
It might.
In that case, we can do that afterwards. But we should probably get through the rest of it.
Yeah, I mean, let's say like your utility function for both is just like is x to the 1/2, y to the 1/2. Then what your x star is going to equal I over 2px, y star is going to equal I over 2py. And if those are their endowments right there, you're going to plug in their income up there, right? So income is going to turn into 52 for both of these guys. Yeah. And then basically for px and py, we can normalize one of these prices. All you guys notice in your problems, they normalize like one of the prices to one. Okay. And if we have that, then we can now solve that system. Does that make sense? That's what you guys have been doing in the problem sets and everything? Right? I think I set that up right. Okay. You guys know why we can normalize one of the prices to one? Yes.
Because price is all relative, like you have inflation, which makes money worth different values, and so you just need something to make it relative to.
It's true, price is relative, but you can consider a situation where, like inflation is a good example. What if they're looking at, different prices with, different levels of inflation in their different like economies and everything, right? So there are a lot of assumptions that we undergo by doing that, but the main reason is we assume perfect competition, and assuming perfect competition, we can use something called Walras's law. And maybe it's Walras, I don't know if he was trying.
Walras, yeah.
Walras?
Yeah.
We'll call him Walras, that sounds cool. Okay, so Walras said that assuming perfect competition in an exchange economy like this, if you have all of your markets clear but one, meaning all of your markets reach equilibrium but one, then that last market has to reach equilibrium as well. So that's Walras's law. Remember that, because if a walrus gets all of your friends, then he will get you too.
I will keep that in mind next time I'm swimming in the ocean.
That's the best explanation I have for that. Okay? So that's where we can normalize prices from. Okay. Any questions about exchange economies left before I jump into the next general equilibrium problem? No. Okay. Perfect. So then, maybe I'll just leave that there.
Quick question, student, sorry,
Yeah.
I have to go, but that practice test you have, is this something that I could like email you for, or?
Yeah, sure.
Yeah, for Thanks.
What is written under 52 on Y star?
That's a 2 times a 1.
The
Oh,
other.
Y star? Oh, that's a PY.
PY, okay, 2.
Yeah. Okay, so we set up this supply and demand problem, and we set up supply just with like endowments, but we want to make it more real than that. We want to actually like bring production into this. Okay, so we're going to bring production into it by saying that there exists some production functions, right? Like some production of x. Let's say, L to the 1/2, K to the 1. Well, it doesn't have to be anything like super specific. I'll just say that it's some function of K and L, right? And another good Y, and the production function for that is some function of L again, right? And so that's the firm side. And then on the consumer side, they have their own utility functions. So you have your utility for person A is going to be some other function of x and y, and then your utility for person B is going to be some other function of x and y, right? So you have now we're expanding a little bit. Instead of just endowments, we have goods that are produced by firms, and we have utility functions for consumers still. Okay, so then we can actually model general equilibrium with firms, and the way we do that is we solve the firm side, and we solve the consumer side. We set, because of perfect competition, we set our marginal cost equal to price, and then we can solve everything from there. Okay, so basically, you would solve the firm side, you would cost minimize, or some of you have been profit maximizing and you've been making that work too. That's either way, on the firm side, you're eventually going to end up with L and K, or L star and K star. They're conditional factor demands, or in other words, they're going to be in terms of Q, W, and R. Okay, so that's how you solve the firm side, cost minimize, or you can profit maximize and plug it back in.
So what did you do exactly?
So this is cost minimization.
So you took the production function of f of x or something like that for qx or qy, and you just minimized it.
It's 380. If you want to go over cost minimization or profit maximization, conditional factor demand, unconditional factor demand.
Oh, right, I understand.
Yeah, that's in my 380 review video on YouTube. You can watch that.
Alright.
So yes, you're gonna do that. And then on the consumer side, you're gonna utility maximize. And then you're gonna end up with X star and Y star. And those are gonna be in terms of your, remember, income is the value of your endowments, right? So you're gonna end up in terms of your endowments and input prices, W and R, and output prices, PX and PY. Right? So you solve the firm side, and you get your conditional factor demands. You solve the consumer side, you get your demands for X and Y. Okay? Then you're going to assume in perfect competition that the marginal cost is equal to the price. Once you do that, you can get rid of PX and PY. Okay? Because you set them equal to marginal cost. Okay? So in that case, you'll now end up with your X star and Y star in terms of your endowments and W and R. And again, because of Walras's law, the assumptions we're making, your problems will normalize one of these prices to 1. And so usually like R. And so really, at this point, you can say that supply equals demand. Okay, so these are your functions up here, right? You set supply equal to demand. You can get your labor demand. Okay, and at that point, you can solve for W, and you will be left, after solving for W, just with something in terms of your endowments, which the problem will probably give to you, and then you can solve everything numerically at that point. Yes?
When you say set supply equal to demand, what are you talking about? Like which supply and which demand?
Yeah, so this Q is quantity. So quantity supplied is going to equal quantity demanded.
For both X and Y?
Yes, yes. So
Okay.
all of these things, I'm writing this shorthand, but yes, it's for both X and Y. That you do the same thing with marginal cost equals price. Do that for both X and Y. But that is the idea behind general equilibrium with production. That was on 4.2, I believe, is what went over GE with production. Now, interestingly enough, if you had if your production functions in terms of X and Y, let's say your QX equals, let's say capital did not matter, and you just had it in terms of labor. So your QX is literally just L to the 1/2, and your QY is literally also just L to the 1/2, right? Well, in that case, you would see that, and this is the amount of, I should write these correctly. So it's the amount of labor you put towards X and the amount of labor you put towards Y. Okay? Then you'd end up with Lx equals Qx squared, Ly equals Qy squared. And then, let's say that, in your entire economy, there were 100 labor hours available. Well, that would be the same as saying that Lx plus Ly equals 100, right? Okay, everything you devote to X and Y, because you're using all of your labor, is going to be 100. Well, then Lx plus Ly, or 100, would be equal to Qx squared plus Qy squared, right? So this is just the equation for what? Does anyone recognize what that? Maybe not necessarily. I can literally graph this in 2D with X here and Y here, and just do that. And that's a PPF right there.
Oh, that's clever.
Yeah. So
That's
but the chances I'm kind of working backwards here. I'm sure you won't be asked to do that specifically. But just so you know, if you get an equation for a PPF, it's the same thing as general equilibrium with production. It's just that there's only one input. So you can now graph it into D as a PPF. And in that case, with one input, it's even simpler because your MRS is going to equal your price ratio, like always, but your marginal rate of what's RPT?
Technical substitution.
No, not that one. Rate of product transformation, that's what I'm looking for, is also gonna be equal to your MRS. So these things are all gonna be equal and you can literally just use those two equations. By the way, your RPT is negative dy dx, if you guys did not know that. But, I mean, that's all you would need to solve a one input problem. Or you could try to do it this way. Doesn't matter. So that's the general idea. I don't, yeah, well, any questions about general equilibrium? Yeah.
So for quantity supplied equals quantity demanded, you'd have two separate equations, one for y, x and one for y, right? Like quantity supplied for x.
Yeah, you have quantity y, you have quantity x. So you would set supply equal to demand in all of those. And that would be after getting rid of the price by setting it equal to marginal cost.
So you basically have to do all these steps twice.
I mean,
Well,
kind of, yes. These tend to be long problems. That is why I thought that it would not be very beneficial to go through one right now. I think this would be the most effective use of time, is just to go over the general concept. And if you want to go through like a whole problem, I would look at homework 2. If you really want to go into that.
Are the homework problems pretty good representations of how hard the test will be?
Dr. Price wrote the homework problems, and Dr. Price, in general, I would say, leans more heavy on the math side of things than Dr. Lewis, despite all the stuff that gets written on the board in class. Dr. Lewis is more concerned about if you conceptually understand what's going on. So Dr. Price also has like very long like multi-part problems where you go through this part and this part and this part and it all like connects to each other. Whereas Dr. Lewis is not as big a fan of that. So yeah, he's mainly worried about do you conceptually understand the topics and the concepts that we've discussed in class. Do you understand why this works? And can you use that to solve? I would say generally more simpler problems, or sometimes problems with like a little bit of a twist. That answer your question?
So it'd be a better kind of pulse to go back and do the in-class, like the in-class quizzes or whatever they call them?
Yeah, because Dr. Lewis wrote the quizzes. Yeah. Dr. Price wrote the problem sets, Dr. Lewis wrote the quizzes.
ChatGPT wrote the quiz.
Huh?
No, I'm just kidding. That's what Dr. Lewis said, isn't
Oh, yeah?
That's right, he did say that.
Oh, well, maybe
it?
with Dr. Lewis's help. Okay, any more problems about GE before we go on?
So if I understand this correctly, all you're doing is you're just doing a minimization of the cost, you're doing a maximization, you're setting the marginal cost equal to the price, so that you can figure out your X star and Y star in terms of L and K and W, and then from there, point supply equals point demand, you get your demand, and then solve for W, and then you have your K demand, and then you can do a general equilibrium, and that's it.
Yeah, by this point, you'll be like, you'll know what's going on. You'll be like, okay, I'm pretty much done with this problem.
So what kind of things could this type of question ask for? Could it ask you for the price of a certain type of thing, or the price of labor, or what exactly is the outcome that a problem like this could ask us so that we can
That's a great question. Dr. Price, his style would probably be to give you a multi-part problem and have you go through this entire process. And each part would be like, some points. Dr. Lewis, instead of doing that, probably will have you do like a specific part of it or ask you about the implications of a specific part of it. So, yeah, yes?
So it's just a semantics question, but on some of the homework problem sets, it would say like, here's an economy and here's a person in the economy with this utility function, and then it would ask you questions about the entire economy. So in that case, do we just always assume that the representative function represents everyone in that economy?
Yeah, the idea of these problems is that it comes from the circular flow model, that you have people that are endowed with labor and capital, and they sell those to firms, and the firms produce products that the people buy. And so in these problems, you'll have a representative consumer, meaning a person that is representing all the consumers in the economy. And you have a representative firm, meaning a firm that represents all the firms in the economy producing stuff.
Okay, cool.
Does that answer your question?
Yes.
Perfect. Well, enough with GE. Let's go to other stuff. Okay, so after that, we talked about risk aversion and a choice under uncertainty. Okay, and this is pretty straightforward stuff. Okay, so basically, this is what a risk averse individual would look like. If I were to draw a graph, this is their wealth right here, and this is the utility that they got from this wealth. All right. Now, if I were to just draw a line like this person would be risk neutral, right? Their utility they get from wealth is exactly what their wealth is, okay? But that's not typically what we see of people's behavior. Typically, we see that they're risk averse, okay? Meaning that they have diminishing marginal returns to getting wealth, okay? So a risk averse individual, you might give them a bet of some sort. Like, hey, there's some probability you'll get this much wealth, and some probability you'll have this much wealth. Okay? Draw this in a little more of a out way. Okay? And so essentially their expected utility is going to be probably somewhere on that line, the average between these two things. Okay? Let's say that it depends on the probability of these two events, but let's say that it's like somewhere like right there is that's their expected wealth and their expected utility. Well, you notice here that they would actually get the same amount of utility from just having a little less money for certain. Okay, so this point is what we call their certainty equivalent. It means, okay, they can have some expected value of this bet, and that's how much utility they would get. Or you could, for certain, offer them less money, and they would take that and get just as much utility from having that. Even though it's less money, they have it for certain. So that is what risk-averse individuals behave like. All right?
How's that point called again?
Certainty equivalent. Yes. Yeah, for example, so utility, I just want to emphasize this, the utility of the certainty equivalent is going to equal the expected utility from that bet, right? So let's say I gave someone a bet. I'm like, okay, there's a 40% chance that you'll get $1,000, and there's a 60% chance that you'll get, well, actually, I should probably be better about this. Okay, so let's say they start with $500, and you're like, okay, here's the bet. Okay, it's 40% chance that you get plus 200, and there's a 60% chance that you get minus 150. Okay. And that's the bet. Okay, so essentially, to get this person's expected utility from this bet, you just apply expected value to this function, right? This is 378 stuff. So you're just going to take the probabilities, the expected utility they get. Well, there's two different situations. Situation one, they win the bet. All right? So it's going to be, let me give them a function here. So this function, risk-averse individuals, you'll probably either see their utility of their wealth equals, root W, or utility equals log W. Those are two functions that look like this graph right here, okay? Let's say it's log W, all right? So I actually will emphasize that there's just the difference between expected wealth and expected utility. Expected wealth in both of these situations, okay? Situation 1, there's a 0.4% chance that they end up with $700, okay? And then there's a 0.6% chance that they end up with $350, okay? That's their expected wealth. But they don't care about that. They care about their utility because they're a risk-averse individual.
Steven,
Yeah.
would you call expected wealth also expected value? Is that the same thing?
Yeah, I mean, technically all of this is expected, we're applying expected value rules.
Okay.
Is there a specific reason?
No, just because he said expected value.
Okay, so when he says expected value, he's probably referring to expected wealth.
Okay.
Yeah, so this is what he would probably be talking about, expected value. So expected utility, so in situation 1, well, their utility is actually gonna be the log of $700. And then in situation 2, their utility is gonna be the log of $350. Okay, so that's their expected utility. If I wanted to find their certainty equivalent, then I would say, well, the utility of their certainty equivalent equals this expected utility. So I would solve this right here.
That's 490 by the way. Or, oh, is it LN? Or
Yeah, log.
that one? Let me see if I can get that real quick.
So I would solve this right here. And then I would say,
6.135.
leave it. And I'd say the log of their certainty equivalent equals 6.135. And I've solved out for their certainty equivalent. Let me just do it right now. Why not? So what? E to the log CE, just gonna give me CE, and then E to the 6.135. There you go, that's their certainty equivalent. Okay, so that is risk aversion. Any questions about that? Okay, pretty straightforward stuff, it's just probabilities.
This section.
I was wondering, for the certainty equivalent, that would be on that would be W, right, like a certain dollar value.
Yeah, correct, it's in terms of W.
So is it the point, sorry, is it that the dotted line or on the curve? I'm sorry,
So the certainty equivalent is
that
this
right there.
value right here. This value of W, this is their certainty equivalent.
He's also shown in class where if you take those two kind of parameters of the bet to the y-axis, halfway between the two bets, that's your utility of wealth for your certainty equivalent.
Yeah.
So it's not gonna be like between not gonna be middle on the w-axis, but it will be on the utility of wealth.
Okay.
Can I ask what that dotted line is again? Maybe I missed it, the black one.
The vertical one?
Yes.
This is just showing, this is how much wealth they expect from the bet. This is their expected wealth. That's their expected wealth. So their certainty equivalent is less than their expected wealth.
So hypothetically, could you find the expected wealth and throw that into the utility equation to find the utility of the expected wealth?
Yeah.
Yeah.
Okay. Perfecto. Okay, so let's talk about insurance and how insurance plays a role in this. So from a, do I want to go from a consumer standpoint? I guess we already did. So from an insurance company standpoint, let's say there's someone that has a probability of having an accident, and they have some probability of no accident, which is the same thing as 1 minus the probability of having an accident. Okay? And let's say that in the event that they have an accident, the insurance company gives them $100, okay? So, the expected payout for this insurance company, okay, how much are they going to expect to pay out to this person? I'll let you guys answer that.
So it's gonna be pi times, well, whatever the value is, or what are we using? We're using 100.
So in the case of an accident, they'll pay them $100.
Oh, okay, yeah.
So,
Isn't that the premium, like equal to Z, is that the same as being equal to Z, the premium?
so we'll get there in about 9.5 seconds. So basically their expected payout is gonna be the probability they have an accident times how much they pay out, plus the probability they don't have an accident times how much they pay out in that case, which is actually 0, right? So that's the same thing as just like their probability of having an accident times how much they pay out, okay? So that is their expected payout for the insurance company. So actuarially fair insurance is where you charge a premium to the person equal to your expected payout. Or in other words, the insurance company has 0 profits, okay? So actuarially fair insurance is where your expected payout is going to be equal to the premium that you charge people, okay? Actuarially fair, meaning 0 profits for the insurance company, okay? So that is how you would do actuarially fair insurance. Full insurance means that in the case of your loss, they cover 100% of your loss. Okay, so partial insurance is they cover some of your loss. So if we were to put some kind of graph to this, and this is the hardest graph for me to draw, so let me see if I can do this well. But let's try to say someone's wealth in the event of no accident, no wealth in the event of an accident. So if someone's provided full insurance, what's going to be the relationship between these two?
It's gonna be
They're going to be equal, right? Your wealth is not going to change in the event of an accident if you get insurance. So that is the line of full insurance, because that's the relationship between these two when you have full insurance. Okay. Now, let's say that we have some people that, because of their characteristics, they're right here. Okay? Let's say we have 2 groups of people, and both of them have the same wealth in no accident and wealth in the event of an accident. They have this much wealth if there's no accident, they have less if there's an accident. Okay, so they both start off there. And the insurance company has some actuarially fair line for both of these individuals based on their probability, based on their risk, the probability of loss. Okay, so group 1, these are high risk people. Okay, that's going to be an actuarially fair line for them. And group 2, low risk people, that's going to be an actuarially fair line for them. Okay, so the insurance company would like to offer, that's kind of straight. Something more like this. Okay. So the insurance company is going to offer them actuarially fair or below, right? They wouldn't offer something more than that because they would lose money. All right, so we got a couple different actuarially fair lines for these people, and high-risk individuals and low-risk individuals are going to have like different indifference curves. And so, let's see if I can draw this. So maybe the high-risk people, their indifference curves look kind of more like that, and the low-risk people, let's say that their indifference curves look more like that, right? Now I've a bunch of stuff on this graph. So essentially, if they're charging different premiums to these people, well, first off, let me ask this. So what would be the issue of charging the same premium to both groups of people?
Adverse selection.
adverse selection, can you explain what that means?
Well, if you like do a pooled equilibrium, I don't know if that's the right term, but like the low risk people are not gonna wanna subsidize the high risk people, so they exit and then you lose money.
Okay, perfect, right? So adverse selection means that you cannot observe the characteristics of all these people. They're hiding the fact whether they're low risk or high risk, or at least you can't sort them out. So that's a problem for perfect competition, which is the theme of this class. Like we're just going over problems with perfect competition. So essentially, if you offer a pooling equilibrium, which is, okay, let me take these people and let me just offer a premium that's, maybe the average between them two, right? Well, like Emmeline said,
Yeah.
basically what's gonna happen in that case is that the high risk people are gonna love it and the low risk people are not going to love it. And essentially they're going to exit, especially if another competitor comes in and offers a better offer for them. And so what the insurance company is left with is just high risk people, and they're charging a premium that is losing money because those high risk people are higher risk than the premium that they're charging. Okay, does that make sense?
Okay, so the high risk people are people who are are they higher up or lower when you give them insurance on the center curve?
So they're this black line. So their actuarially fair line is lower.
Okay.
The actuarially fair line for the low risk people is higher. Okay, that's this higher line right here.
Is that because the wealth that they have is Can you explain that to me?
Basically this is their wealth in the event of no accident, this is their wealth in the event of an accident. So high risk people in the event of an accident are gonna give up a lot more wealth. Low risk people not gonna give up as much wealth in the event of an accident. So what would happen in this case is that you would have high risk people and they would offer, I don't know if I'm gonna draw this right, so I apologize. I'm not good at drawing this graph. So on this full insurance line, they would offer high risk people full insurance. And that would be great for the high risk people, okay? And then they would offer, shoot, I didn't draw this very well. Yeah, I'm just gonna change these indifference curves a little bit.
So high risk people will be offered full insurance.
Yeah, wait, no, that's bad, that's bad. Didn't want to do this. Maybe I did draw this right. Okay. We draw it like this, okay. Imagine that this is the indifference curve for the high risk people. And imagine that this indifference curve for the low risk people. Okay. And they charge that to the low risk people. They give them partial insurance. Okay? So notice that the high risk people are gonna take full insurance because accepting the offer to the low risk people would put them on a lower indifference curve. Does everyone see that? That's great because my drawing is absolutely awful. Okay? But I'm glad that you get what I'm going for. So they offer the full high risk people some expensive full insurance plan, and they offer the low risk people a cheap partial insurance plan. And what happens is these people see these premiums, and without knowing their characteristics, these people just sort themselves into these groups because of their indifference curves, because of their utility functions. And that is what we call a separating equilibrium. Okay. Yes.
So what? I'm just like I'm not tracking what. Why are the low risk people not getting full insurance, but the high risk people are?
So remember at the beginning, this is the full insurance line.
Right.
Okay, so any point on this line is full insurance.
Yep.
these are the actuarially fair lines, right? So that's what's actuarially fair, and this is no insurance. This point is no
Oh, I got you. So it's because the indifference curve that these high-risk people are on, it runs through the point and through the full insurance line. But the indifference curve that these low-risk people are on doesn't run to the point, but it runs through their line, and so they're not getting full insurance.
Well, these indifferencers are infinite, so they do have, low-risk people do have an indifference curve that runs through here, right? But we're not gonna charge them full insurance, because if they if they offered them full insurance, then the high-risk people would take it.
Okay.
So that's why they're not offering full insurance to low-risk people, because they don't want the high-risk people to take it. So the way that they separate them out is they offer an expensive full insurance plan, and they offer a cheap partial insurance plan. And people sort themselves.
And the people that are low risk are gonna take the cheaper option. Cheap people that are higher risk are gonna take the full coverage option.
Exactly.
Which curves belong to who again?
The black are high risk, it's just the color, that was the.
Okay,
The red are low risk.
Hold on.
I wasn't gonna go there, Steven, but cool.
Yeah, I'm still not super clear on, like, I understand the curves and the slopes. We haven't talked about the slope, the definition of the slope, but that helped me a lot, like the probability over, the negative probability over the 1 minus the probability of the accident. And I understand the slopes of the actuarially fair lines. I do not understand why they both start off with the same WN, WA, and then they have different at the same full insurance rate. Does that make sense? So is that because one party is paying more? And so, does that make sense?
So you're wondering why the actuarially fair lines are different?
Well, I know why they're different. I don't understand why the values, like the XY values, are different intuitively.
You mean like from the bottom point to the top point?
Yeah, because they have different XY here and then different XY here, even though they started with the same XY.
Because they're paying different premiums. So the person who's high risk, they have to pay a higher premium. So on the full insurance line, they're going to have less wealth because they have to pay more for their premium.
You're giving up more wealth
Yeah,
with not an accident.
and that makes sense why both of them are gonna have less without wealth with no accident. It goes down either way. Yeah, that makes sense.
That answers your question? And then, does someone else have a question? Emily, do you have a question?
No, sorry.
All right, perfect. I was worried about that. That was hard for me to go through. But
How do we do?
that's a graph.
It's a graph. There's a lot you can read about it in the lecture notes too.
Yeah. There's an actually accurate graph in the notes.
Well done.
But that's pretty good. I mean, for my, I haven't drawn that in like
You should go with your trackpad.
a long time.
It's
Okay.
amazing.
So we went over pooling versus separating equilibrium. We talked about adverse selection. Problem 3 on your homework 4 is a great example of what we call moral hazard. Okay, so you guys, hopefully you all did problem set 4. There's a guy named Edgar. He's got a phone, and the insurance will partially cover loss of his phone. Okay. And so what's different in Edgar's situation is that his probability of loss of his phone is going to be some function of the precaution that he takes to not lose his phone. Okay, so that's the big thing that's different in problem 3 and homework 4. And so because the probability depends on his precaution, having insurance is going to change his level of precaution and therefore his probability of losing his phone. So what you found out in problem 3 is that when he buys insurance, he takes less precaution and he has like a 90% chance of losing his phone.
every
You
year.
got that right. That sound, it felt wrong.
Yeah.
I was like,
Yeah.
That's right.
No, that felt really
Yeah.
good.
Yeah, I was like, this is weird.
I-
Wrong.
91% chance of this is wrong.
I had no idea what I was doing too, so.
Well, there you go. Yeah, that's what happens to him. So we call that moral hazard, okay? That's when you're protected from the consequence of your actions, so your behavior changes. So that's what happened to Edgar, and that's why, it would be beneficial for him to hire somebody to watch him and make sure that he engages in precaution to not lose his phone. Okay, that's the whole point of problem 3 on homework 4. It was super good. But that is the essence of moral hazard. That's what that problem was essentially teaching you. Okay? So, moral hazard, there you go. That's a great representative problem. And then, honestly, the only other thing conceptually that comes to my mind that we've talked about is signaling. Just the concept of, which is problem 4 in homework 4. That's a great example of that. So signaling essentially is where there's some, cost to signal what kind of person you are. In homework 4, you had you had good students and bad students, right? And the condition for a separating equilibrium there was that the good students, or the cost of, let's see. So this CG, this is the cost of getting an A for a good student. Is it easier for a good student to get an A or a bad student to get an A?
It's a good student to get an A, right?
Easier for a good
Maybe.
student to get an A, right?
Hope.
So that's gonna be less than the cost for a bad student to get an A. Okay, so it's less expensive for good students to signal than it is for bad students to signal, right? Okay, so for a separating equilibrium, you do need that, obviously, but you also need that the payoff is going to be good for them. So that's gonna be the difference between the good wage and the bad wage, right? So their cost of signaling, it has to be less than the payoff that they're gonna get in terms of a wage increase. And that has to be less than the cost of signaling that you're a bad student, because otherwise bad students would just signal that they're good students. That was the essence of problem 4. You don't need to memorize this formula. The reason that for these past 2 I've just been writing a couple things on the board and talking about them is so that you guys can conceptually understand these things, because that's what Dr. Lewis cares about, is do you conceptually understand these concepts, not can you memorize these formulas and reproduce them. So, but that is the essence of what signaling is about. It's about, there's 2 groups of people, and what's the cost of sending this message? And one group of people will send that message, and the other person will find it too costly to do that. And so you see this in things like he talked about the other day with, what was he talking about yesterday? Or not yesterday, but 2 days ago.
Was it the example of the workers on the quiz?
Yeah,
It was
right.
the one of there being high skilled and low skilled workers.
Right, and you accept a low wage when you go in, and then they find out your productivity. And then, based on your productivity, then they'll give you a higher wage, right? That's the same concept of signaling. So that's actually pretty basic. I don't want to spend a whole lot of time talking about that. It's not its own section or anything. But everything I've covered thus far is everything we've covered in class. That I know of, unless you guys can think of anything else. But
So game theory and stuff won't be on the test.
game theory will not be on the test.
So lectures 1 through 9, right?
Yes, I believe so.
So it's general equilibrium, choices under uncertainty, and insurance.
Yeah, insurance is kind of related to that.
Yeah, and then, well, how do you describe this stuff, the cost and, is it worth the signal,
Signaling is actually kind of related to choices under uncertainty as well. It's related to information. It's related to related to adverse selection, because you can't observe the characteristics of every group. So you need some way to make a separated equilibrium. You need some way for people to self-sort themselves.
Right. is there like a place you can go to see like, not like potential questions, but like the type of questions that will be asked?
Yes. So if you guys want, it's 6 o'clock right now. If you want, I can go over
Yes.
really quick a kind of like practice exam type thing.
Yeah.
Let's do it.
Show you what the format might be like.
Would be awesome.
I forgot
Is,
about that.
is this like Dr. Lewis's or like Dr. Price's?
Like Dr. Lewis's. Yes.
Cause he told us in class it'd be about 10 true false, 5 I think wordy problems, and then 6 mathy problems.
Yeah, something like that.
Those are the words he used? Then I was like, oh, okay, good. That's really descriptive.
She's like, yeah, what would that look like? He's like, you've written before, I'm like,
It's like, oh.
That was the goal.
Nice. Let's go. Okay, so everyone, welcome to Steven's awesome practice midterm.
Yo!
Wow.
Steven's awesome practice midterm? Where
So
do I download that bad boy?
this is I don't know, maybe you'll like, I don't know.
you should share it with everyone who
Send it
came
out
to
as you buy
review.
dinner.
You know what?
Only people who go.
You should airdrop it.
Just here. Maybe I'll post it on Learning Suite.
Steven, awesome.
Yeah, or send it on an email or something. Okay, so here is, this might be like the format pretty much of your actual exam. So it's gonna be some true or false questions, there's gonna be some short answer questions, and there's gonna be some, don't look at those, and then there's some longer answer questions that have like a little more math. I won't go over the longer ones today, but let's just go over the true false. So what do you think? Pareto efficient allocation can never be considered inequitable.
False.
False. Okay.
You go doing them corners.
Right. Why is it false?
Because you can be Pareto efficient and have like 99 beans and 1 bean, and that's not equitable.
Sure. Exactly. Okay. True or false? Walras's law implies that if we find a set of prices where demand equals supply and market for goods, then the market for labor must also be in equilibrium.
False.
That is true. That's Walras's law says that if n-1 markets clear, then the last market clears as well. So what this is saying is that the market for goods, right? If that market clears,
What about capital though?
It's like one thing more clearing leads one other thing.
Well, yeah, there's not. So there's, I think the way it is in the circular flow model is there's a market for goods and there's a market for factors of labor. I mean, market for, what do you call those? Goods and then factors of production, there you go. So that's essentially what it's saying. So factors of production would be labor and capital.
Cause like the markets, like those two markets kind of rely on each other. So
Yeah.
if one of them's in equilibrium, the other one has to be.
Exactly. Okay, true or false, in a separating equilibrium, the contract offered to low risk is designed to be unattractive to high risk, which may result in the low risk receiving only partial insurance.
True. I'm pretty sure that's what it is. I mean, it makes sense. I don't know if that's what separating equilibrium means, but.
Yeah, that is true. True or false, moral hazard arises because an insurer cannot observe a person's risk type, whether they're a safe or risky driver.
False.
False, why false?
That's adverse selection.
Actually, that's adverse selection. What is moral hazard?
It's what they are predicted.
When you have more coverage, you're gonna risk
Because when you start acting stupid, you have insurance.
Yeah, it's where your behavior changes. Okay, so true or false, public good is an example of market failure because it's non-rivalrous, non-excludable, leading to underproduction in a competitive market.
True.
That is true. Alright, that's yep, it's just market failure, which we explore a lot in this class. True or false, oh, it's touchscreen. True or false, for a firm in a perfectly competitive market, the marginal rate of technical substitution between labor and capital must equal the ratio of the wage rate to rental rate of capital.
True.
That's true, you get that just from doing your Lagrangian, right?
Yes.
If a used car market has both lemons and plums, the equilibrium price will equal the average price of lemons and plums.
False.
False, why false?
Adverse selection.
Can you elaborate?
The plums are, the people with good cars won't want to sell their cars for less than they're worth, so only the bad cars are left, and then
Right, so the equilibrium will probably be the good people exiting the market. Okay, so yeah, you're not gonna end up with an equilibrium of the average price of the two.
This is actually the basis of one of the most famous econ papers I've written.
For a risk-neutral individual, true or false, the certainty equivalent of a lottery is always equal to its expected value. True.
Not always, I don't think so.
Yes.
Risk
They're risk neutral.
Oh, risk
It's a-
neutral.
Yeah.
It's like
Okay.
a,
Yeah, that's a tricky one, okay? So, risk neutral means that they're like that straight line right there that I drew. True or false, the second welfare theorem states that any Pareto efficient allocation can be achieved as a competitive equilibrium, provided we first redistribute the initial endowments.
True.
That is literally what it says. True or false, a risk-averse individual will always accept a bet that is better than fair.
False.
False, why false?
Because it would have to be a lot better than fair. It could
Right.
be just a little bit better than fair.
Yeah, it depends on how risk-averse they are, what's their expected utility, yeah.
So for true false, you have to say it's true or false. You already have to back it up with something.
You can just say true or false.
Yeah.
And,
that.
and then add Stephen is cute or something. Okay, sweet. Let's go over short answers and then we'll stop there. So here's an example of a short answer. Give an example of a market failure due to a negative externality and explain how a government policy like a Pigouvian tax can restore efficiency.
What is a
Getting
Pigouvian tax?
easy like this? Okay, so a Pigouvian tax is when they specifically increase the price of something, so that it goes to the externality price as opposed to the market price.
So like emissions from like gas cars, so you tax the crap out of gas to try to get people to drive electric?
Something
Well,
like that.
Perfect.
Yeah, to offset the negative.
Yeah, the negative
External.
effects of
Yeah,
pollution,
yeah, probably-
emissions.
Yeah, it's probably not accurate to say tax the crap out of it, but yes,
Technically speaking.
I wanna put that in quotes. Tax the crap.
And then Stephen is cute.
And Steven's cute with a smiley face.
On an island. He could spend his time either gathering coconuts or weaving nets. Explain how his optimal choice represents a Pareto efficient outcome. Okay, answer that first.
Is this, okay, so he lives alone on the island.
But don't we need two people to have Pareto efficiency work? No?
So what's the definition of Pareto efficiency?
You can
You
make.
can't make one person better off without making the other
without
person.
harming another person.
So he can't make himself.
He can
Better
make
off.
himself better off. He can't.
Not to a point.
So no matter what he does, he's Pareto efficient.
So long
yeah,
as
I
he
think-
spends
I think
all.
essentially that's the idea.
I would
That's the
say-
answer, like, doesn't matter what he
I
does,
would
it's
say
Pareto
it's
efficient.
Well, so
not
long as he
guaranteed.
spends all of his
Wait,
time.
so if he just sat there and let himself die, that's Pareto
okay,
efficient?
well,
I mean, he's exhausting all of his resources. I mean, he's
It
exhausting
says
all of his
explain how his optimal choice
And
Oh.
represents a Pareto efficient
what do
outcome.
you mean by
so
optimal?
if he's really depressed, that might be.
That's crazy.
Well,
His optimal choice is going to make himself as well off as possible, right?
okay.
Therefore, no one can be made better off.
Well then, yeah, his original allocation is not on the is not necessarily on the contract curve, is it? Because he has more resources.
I don't know if there even is a contract curve because there's one dude.
That's what I'm saying.
I thought we were.
Why is he still asking about that contract curve?
There's a reason that I'm giving you a question like this. It's because it's because
Dr. Lewis
there's
told
gonna
me
be
what-
some questions with kind of twists on
So-
the
so
test.
what's the answer? Would you just say like, if he makes his optimal choice, any other choice would make him worse off?
You could say that. There's basically like the logic here, the way I would describe it is like he's gonna make himself as well off as possible, therefore Pareto efficiency, because he can't make himself better off than that.
Assuming that he's using all of his capital and labor, he's gonna pick the optimal solution, right? I mean,
Yeah, again, it's assuming he makes the optimal choice.
yeah.
So it's not that deep, and you can like as long as you essentially conceptually understand that, then you can just write that and then, you know, all kinds of answers that understand the concept will be accepted, right? And then if Friday then arrives on the island, which I don't know who that is, but
Oh, that's a person?
yeah.
That's,
Is Crusoe's original allocation still guaranteed to be on the contract curve?
No,
And why no?
because we don't know his indifference curves.
Yeah, I mean, we don't even know his original allocation, right? If this said, is there equilibrium allocation guaranteed to be on the contract curve? Does that change the answer?
Say that one more time.
Assuming, okay, if we were assuming perfect competition and it said, is there equilibrium allocation gonna be on the contract curve? That would be true. That would be true.
Yeah.
But since it says his original allocation, no, that's not guaranteed to be on the contract curve. And so they would likely trade.
It's not gonna be guaranteed, it's it's a possibility, but that's not gonna.
Yeah.
So it's just saying maybe trading with her.
And her. Yeah. Okay, so you guys. So, alright, and there's some long answers, I'll probably post this, just so you know, I use like Gemini to write this, and I have not actually done these problems, so. So,
I saw them.
who knows? Who knows how those are gonna turn out?
how more accurate this is for the test.
How lore accurate, so this is the format of the test, there's gonna be some true false, there's gonna be some short answers, and there's gonna be some long answers where you do, like these short answers you write, and these long answers you do like some math.
I kinda like those short answers, it's kinda cool.
Yeah, the short answers are cool. Yeah, but that's essentially how it's gonna go. Any more questions? Yes.
So with the Pigouvian tax, will we have to know like terms like that from 380 that we haven't specifically gone over in this class?
Has he not mentioned the term Pigouvian tax in class?
He said it like one time.
Yeah, he wrote
He did.
externalities,
Yeah,
public
it's like
goods,
one of the
public goods.
It's an example of,
And then that day we didn't do any math.
He was.
You guys remember
Yeah,
that?
so you should
We didn't do any math that day?
You should know, you should feel confident in just like, essentially like, what is perfect competition? What are the assumptions of perfect competition? What are the solutions to market failures? What are examples of market failures in perfect competition, and what are solutions to those? That's essentially. Alright, thank you guys.
It's like the stuff that I sent you.
Like, we didn't know something.
Because I think I wanna ask them.